With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this problem, consider the situation shown in figure. The wire AB is sliding on a fixed rail with a constant velocity. If the wire AB is replaced by a semicircular wire, the magnitude of the induced current will be. So, first of all, I am just going to redraw the circuit. So, this is fixed rail, okay? And the magnetic field is given perpendicular to the plane inward. And there is a wire whose name is AB, okay? So, this is AB and this is fixed rail. Consider the length of wire AB is small l and resistance as R ohm, okay? And it is moving with velocity v and magnetic field is given as B. So as we know that motional EMF of wire AB can be given as EMF equals to V cross B dot L, okay, where this is displacement vector. This is what? This is displacement vector between the between the A and B. So what is its displacement? Its displacement is the shortest possible distance between A and B, and shortest possible distance is L, and all L, velocity and magnetic field, all are mutually perpendicular to each other, V, B and L. So EMF will be equals to VBL, and induced current I will be equals to E upon R. So this will be equals to VBL upon R if we are going to connect this circuit. If we are going to connect this rail, there will be induced current I will flow through the circuit like this, okay? So induced current, oh sorry, I have made the wrong direction, so I have to change this direction also. So this was a wire AB and the higher potential will be B, so direction of current will be like this, okay? Now if we are going to replace with a semicircular wire, so replace with a semicircular wire and providing it the same speed. So consider this is a rail, fixed rail, and this is connected at some points, and there is a semicircular wire. So I am going to draw the semicircular wire like this, and considering the length between the rails is L, okay, and consider its radius as capital R, its resistance is R ohm, okay, and it is also, there is also magnetic field perpendicular to the plane, and it is also moving with velocity v, okay? Now if I am going to solve this, if this is point A and this is point B, then motional EMF can be again written as E equals to V cross B dot L, where L is again displacement vector, and displacement vector is the shortest possible distance between the two ends. So the shortest possible distance between A and B will again be L, okay? So the EMF will be again V cross B dot L, and all three are perpendicular to each other, so again the EMF will be VBL, okay? So induced current can be given as I equals to E upon R, then it will be VBL upon R. This is the induced current for semicircular wire, and this is the induced current for a straight wire. What we are looking? We are observing that the induced current is same, so it will remains the same. So induced current will remain same. Induced current will remain same. This is the, so induced current will remain same. So this is the answer of this problem. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.